Welcome to the Micronaut podcast. I am your host, Sergio del Amo. Graeme Rocher, Micronaut co-founder, is joining me today. How are you, Graeme?
Good, thanks. How are you?
Good. We are in Micronaut 3.3.0 release date. It was released yesterday. So great news. It feels to me it's a huge minor release. And I think that's probably a sign of that we are a mature team, that we have more features in minor releases than in major releases. I think that's a good thing. Do you want to give a roundup of what's new without going into much detail?
Yeah, I mean, sure. It's like you said, it's a big release with lots of different things in it. Lots of different features, and there are some of them are in preview and some of them are GA, but you try out. And it was a huge release with lots of different contributions from lots of different contributors because we have so many now. So from my side, I'm excited about Micronaut Serialization, which I guess is part of the topic of this this podcast. And so we'll be talking about that in more detail. So I won't go into too much detail on that. But we have now Micronaut AOT as well, available via Micronaut launch. So we kind of, that's in the milestone preview phase, but it's evolving and it's getting better. So folks that don't know what that is, basically does a kind of build plugins for Gradle and soon hopefully Maven that look at the whole application and optimize it. I'm sure it was discussed previously in the podcast.
Yeah, we have an episode with Cedric. So that's episode 5. So yeah, that's a good episode to catch up. AOT is really exciting.
So that's cool, and it's furthers the mission of making Micronaut more optimized to build time, more intelligent in terms of compilation, smaller runtimes. Then there's lots of little things like have the access style annotation, where you can alter for a bean introspection, which you said we will talk about as well. Bean introspections, but basically, if you're using something other than getters and setters, Java beans or records, then you can change what represents a getter and setter in terms of the style for bean properties. And we had a milestone of, for example, support for TOML and configuration, which is nice for folks who don't like YAML, which is a growing percentage of people over time can switch to TOML or doesn't have the white space issues, I suppose. And we also have a new Kubernetes module that has support for writing Kubernetes operators with Micronaut, which is really neat. I'm sure you're very familiar with the new email module, which is really cool as well, where, given that you wrote most of it, which is really cool. I really particularly like the fact that you can combine it with the Micronaut views to write as emails. That's really sweet. And then of course, run against the backend. Half of what you're trying to achieve with Micronaut is to make it portable across different clouds and so forth, just by reconfiguration. So that's a big step in that direction. And then in Micronaut security, we have X5i9 certificate support for mutual authentication. So that's a nice addition. The JSON module was also split out. There are some things happening as well outside of Micronauts, like core release cycle. Like, for example, we have been working on contributing to the Open API Generator project, so that you can generate API clients and servers from Open API specifications for Micronaut. And that's another new thing that's coming. And then there's also which I'm really excited about as well, which builds on Micronaut Serialization, is a kind of preview, not final yet, but folks can try it out. Support for MongoDB and Micronaut data, which is, I think it was one of the most voted for issues on Micronaut data. So we'll talk about that not for a long time. And So what that means is effectively we have the repository pattern for MongoDB. So you can define new entities and just write interfaces and get all the goodness of Micronaut data but on top of MongoDB. And from and recently as well that on our cloud you can Oracle database has even implemented the MongoDB API so that you can run MongoDB applications against Oracle database as well. I think other clouds are doing similar things. Like I think Azure has like Cosmos DB, which is not really MongoDB, but they have like a Mongo API and so forth. It seems to be a common thing is to, MongoDB is becoming like the protocol and different clouds have their different implementations.
Yeah, I have not tried myself Cosmos DB, but everyone that I only hear good things about it. So yeah, it's good that there is like a more or less a de facto standard for accessing non-relational databases. That's great.
Definitely. So lots of exciting things in Micronaut 3.3. Some of them, like I said, are not quite yet. Preview features like Micronaut Serialization, Micronaut data MongoDB, but certainly if you want to try it out and give us feedback for those things go final. Like now it's the moment.
Yeah, please do that because your feedback really influences the development of the framework. For example, in Micronaut Security, we had users who were using Micronaut Security with JavaScript frontends. They wanted to use cookie-based authentication, but by default, we were like redirecting. So they actually didn't want a redirection. They just wanted to get the cookie back, and we actually make a redirection toggable in the latest minor release of Micronaut Security as well. Please do give us feedback because that helps a lot. When was GraalVM released, the latest one?
Yeah, GraalVM 22.0 was released just last week. So Micronaut, like this is Micronaut 3.3 also works fine with it. GraalVM becoming more and more stable, and hopefully it'll arrive at a point soon where, there won't be a coupling between a Micronaut release and a GraalVM release, and that would be, just use the latest and greatest of each. But the new GraalVM release is also really exciting because, for one, they've improved build times, which is awesome. Native image, faster build with native image are always a good thing.
Yeah, absolutely.
And also they improved the output from the native image tool so that you can, when you build native images, you get better feedback, better usability. So I think that's a big deal. And yeah, we've been involved in the feedback loop on that output. And then there's a new GitHub action as well. So we've, historically been reliant on community GitHub actions, but now there's an official one for building native apps on GitHub actions. Really nice, and I think we've already adopted that across Micronaut projects. I think a lot of our builds, so that's cool.
I read a tweet the other day that it's not just official; it seems to be great because I the other day I read a tweet like someone who was like struggling to have like build times timing out, and they switched to the official GraalVM GitHub actions, and they were like getting builds in no time. So that's great. I think a lot of good things are happening around GitHub Actions. Seems GitHub Actions is really becoming a power force in the continuous integration side of things. So that's fantastic. Let's move to the level up section and let's discuss about at introspected. So I don't remember when we introduced at introspected, Graeme, but it was a long time ago. And what I always have said is I like to write my Micronaut applications with POJOs, which they're really plain POJOs in Java with just a constructor, getters and setters and fields. And I always said, annotate all those POJOs with that introspected, and that was more or less my rule of thumb. Why should people do that? Do you think that's a good idea? And what does at introspected do?
So the name at introspected, let's first talk about the history of that, because maybe people don't know, what that means. But basically, historically, in order to find out what properties a Java bean has, so Java bean was kind of a loosely described specification for a way a class in Java has property. So a property is a private private field with getters, like with a getter and or a setter, right? That follow the convention. And that the Java Bean convention has been around for a long time. And Java added an API to get all the properties, which was a class called java.beans.introspector, right? So you can do java.beans.introspector and say, get me all the properties of this type, and it would use at runtime reflection, Java reflection, to get all the properties of that type, all the metadata about what the property names are and what the property types are, etc., etc. And obviously based on 100% based on reflection. So with Micronaut, we've been trying to eliminate the need for reflection so that we can speed up reflective invocation, and also not load any reflective metadata, right? Because the less reflective metadata that you have in the application, the more you can optimize memory. Because reflection is like a little bit of an all or nothing thing. Like when you ask for reflection information for a type, it's like it gives you everything, right? All the constructors, all the methods, all the fields, every private, there's no way to say I only want like these 3 methods or. Yeah. So what bean introspections are and what after introspector does, you add it to a type, and then at Micronaut at build time will generate what's called a bean introspection, which so it'll look at the type and it'll figure out which ones are the properties at build time, or if it's on a record, which ones are the record components, and it will at build time generate a class that's able to instantiate that type without reflection, and B, read and basically get and set properties on that type. If they're mutable, be able to set them. If they're immutable, just get them at runtime without the need to actually use any kind of reflection. So it's more or less a build time version of java.beans.introspector, and also it computes all of the kind of annotation information at build time. So you get these really lightweight objects that you can instantiate a type dynamically. You can take that dynamically instantiated type and find out what properties it has. You can iterate over those properties, and you can set those properties dynamically. So what is the use case for this? Well, think about I want to kind of serialize an object to JSON, for example. You have to get the object. You have to find out what its properties are. You have to dynamically read them and then write them to JSON. Or for example, you want to save read an object from a database, right? You have to execute the SQL. You have to dynamically instantiate the type that you're reading from the SQL result set. You have to read each column in the SQL, and then you have to dynamically set each property. And obviously, the majority of frameworks out there, prior to Micronaut, relied on the use of Java reflection to do that. And Micronaut doesn't.
An example that I always like to give and that I have used, and I think is easy to understand as well, is we often have web applications where you get like a CSV file or an Excel file, and you get like the column names, and you want to like loop through the rows in that Excel file and instantiate an object.
Yes.
And you want to populate the field given the name in the column name. So if you are mapping your Excel rows to a Java class in Micronaut, which is annotated without introspected, you can do the instantiated of that class and the population dynamically without using reflection. So yeah, as you see, there are many use cases. When you first think about it, you think like it's like kind of a thing that you will never use, but actually there are many cases when you are like going from a non-Java world, such as a database, a JSON object, a CSV file, to the Java world, and in those cases, at introspective comes really handy. And we will see that the serialization support is built on top of this reflection-free introspection.
Yeah.
Do you think it's like a good idea for people to annotate their pollos without introspective?
Yeah, well, I mean, it's if they're going to be used in any of the cases that you want, I wouldn't like edit every single photo. But if you're going to be saving the object, to database for sending or serializing it to JSON, then it's definitely a good thing to add. Right?
For example, when you use Micronaut data and you use that mapped entity, that is annotated as mapped entity is annotated as well without introspected.
So that introspected can be used as like a meta annotation where you annotate another annotation. So whenever you put app mapped entity from Micronaut data, mapped entity is actually itself annotated with app introspected. So Micronaut data uses introspections to effectively like read and write objects to whatever database. So in Micronaut data ADC, it's with SQL, and Micronaut data MongoDB, which we just mentioned it with Mongo, right? But it's more or less the same. In order to instantiate an object. And the cool thing is that regardless, because one of the challenges is that there's different styles that I mentioned of the what a property represents. So, for example, a property can represent a Java bean getter. So, like I have a book class and it has a get title property. But it could also represent a record component. So, like I have a book record type and it has a title component, or it could represent, some other way. And what the bean introspection API provides is like the same API to basically read properties, find out what the properties are of a type, and read them without you having to know, like, is this a record, or is this a Java bean getter status, or is this some other style of like. So you just use the same API, and we can consistently handle those different types at build time.
So with that unexpected introduction, let's move to talk about serialization. But before doing that, let's cover the agenda. In agenda, we talked in the beginning of the episode about Micronaut 3.3.0. So I think that's the biggest topic in the agenda. Please do check it out and try to update your applications and give us any feedback. In Pure Talks, I am talking in the Manchester Java user group. It's an online talk and is happening in March. Let me fetch the date. It's March 17. So I will include a link in the show notes for the talk. If you want to attend, it's going to be a talk about Micronaut introduction. So if you are new to Micronaut, don't hesitate. It's an easy to follow talk. We also have a Grace and Micronaut training upcoming. And if you give me a second, I will give you the dates. The dates for that is February the 16th until February 17th, so it's 2 days. Again, I will include a link in the show notes. And your talk in Stockholm, Graeme, if COVID allows, is coming in May the 3rd. So hopefully the COVID situation will clear out and those in-person events can happen.
Yeah.
Do you have anything else coming?
Yeah, actually, I just got accepted to a few conferences. One in particular, which is J on the Beach in Malaga.
Cool, in Malaga.
So that I just got accepted yesterday. Updated you all yet, but that'll be fun. Go to an in-person event. I think that'll be the first in-person event I'm going to go to. Do look out for that. The agenda will be published soon as well.
Yeah, I will click a link in the show notes. I have it the webpage in front of me. Please also, if you are interested in Micronaut.io events, you will find always links to the events. So no need to listen to the podcast to catch up on events. But if in the website, we are always trying to list them. If anyone listening to the podcast is doing any micro talks, please reach out to me and I will try to include your talk as well in the Micronaut website. And without further ado, let's move to the main section. Today, this episode was dedicated to Micronaut Serialization, which is this module which we are recording this on Friday, and we will announce this module on Monday. So I will include a link to the official blog post announcement. This is a module where you have been quite involved with, together with Dennis and Jonas as well. Let's start, Graeme, about what is Micronaut Serialization.
So, obviously, since the very beginning of Micronaut, I think since 1.0 or 0.1 or whatever you want to call it, Micronaut has used JSON for serializing and deserializing JSON object. And that is a great choice because JSON, is a very popular library in the Java community, and we all do love Jackson. So there's so first thing to state that Micronaut will continue to support Jackson going forward, because it's a much loved library that everybody likes. But it does come with its costs. So Jackson is fundamentally based on reflection. So we have been trying a long time to make Micronaut end-to-end reflection free. And I think this is like the final piece. You see what I'm saying? Where you can build a completely, like with the Micronaut serialization, this is the first time you can take a complete, you can build an end-to-end app that, serializes JSON on the REST, in the REST API, reads and writes objects from the database on the back end, and, doesn't use any reflection whatsoever in that entire front end, back end interaction. And, why, if you look at the reasons why with reflection and runtime analysis of reflected data is quite expensive, both in terms of like memory consumption, but also in terms of the footprint of the library. So if you look at Jackson, it's like a something like 2.1, I think I looked up last time, megabyte jar file. This is Jackson data bind, right? And it has a massive amount of infrastructure, runtime infrastructure needed to essentially like analyze your types at runtime. So it builds all this like information and so forth. And the thing is with Micronaut, we already have a way to compute all that stuff at build time. And we did implement a module for Jackson that allows you to plug into bean introspections and so forth, which kind of half solves the problem by getting Jackson to reuse Micronaut introspections. But it's still, Jackson's fundamentally coupled to reflection, and we see issues like coming up. So with Micronaut serialization, what we wanted to do is, have a way to serialize and deserialize JSON, but not just JSON, also other formats like BSON for MongoDB, in a completely reflection-free manner with bean introspections, and shift all of the logic needed to compute how your objects map to JSON to build time, so that we don't have to execute it at runtime. So Micronaut serialization will also like analyze your classes at build time and do all the computation necessary at build time to figure out, which are the names of the properties that the JSON properties that your types map to, which properties represent JSON values or JSON unwrapped or JSON, all the typical Jackson annotations. But do all that analysis at build time. So at runtime, it's much smaller, and the net result of that is like Micronaut serialization is like 400 kilobytes footprint, right? And that has a big impact on native image sizes as well. If you build a native image memory, the image size is 4 megabytes smaller because there's a lot less code at runtime, needed. And the other impact it has is on type checking, which is a real productivity benefit. So Jackson has like an annotation-based programming model where you say, at JSON property or at JSON value or at JSON unwrapped or at JSON format on different properties. Customize how it maps to the JSON. And all of those annotations are validated at runtime. So for example, if I do something like that's not allowed, say, for example, I use JSON format with an invalid pattern. I get a runtime exception, right? But with Micronaut serialization, we can check all of that at compilation time. So you get active compile time checking of your, a JSON mapping syntax. Another example is, for example, if I use @JSON unwrapped, what @JSON unwrapped does is it embeds the properties of one type into another type. But if both types both have a JSON property called name, you have a conflict, and that results in a runtime exception. Oh, I can't unwrap this object into this object because both of them have a name property that's going to go into the JSON, and that's invalid, right? So again, we at compilation time, we perform the analysis to say, oh, you can't do that because you have properties that will conflict, and you need to provide a prefix. Another example is you can't have more than 2 JSON properties with the same name. So if I have JSON property foo and I have another thing that's also called foo, that's 2 properties that can't exist. So we check that at compilation time and fail compilation actively in your ID, which eliminates the need for a lot of like runtime checking errors and the state of the model. We know the model's going to be correct runtime. Just check compilation time.
It reminds me a lot so the type safety checks, they are kind of, in microdata we do it as well. And it's something like, you don't think about it, but I think it gives a lot of developer productivity back.
Yeah, definitely.
The errors are caught early. One thing that I wanted to clarify is, so you have been describing scenarios where you were like talking about different JSON annotations. And I want to clarify, those are the JSON annotations. So can you explain the difference between JSON data bind and JSON annotations? Can users of Micronaut applications that are using things such as JSON properties still use those annotations, or do they have to replace them?
Yeah, that's the thing, is that we wanted to build something that was familiar. So JSON is actually pretty modular as a library. It has JSON annotation, which is a library that contains all of the annotations. It has JSON core, which is the parser and the generator. And then it has JSON data bind, which is the really large data binding framework that builds those two. So Micronaut serialization works with a number of different source code level annotation programming models. So we have support for JSON annotations, and we support like 90% of the different annotations that JSON provides, right? So you can use the majority of the JSON annotations. I think there's some exceptions. We don't want to support JSON raw value for security reasons. That's not a great way. But the majority of annotations are supported. And one of the cool things about Micronaut serialization is, and Micronaut in general, is that we decouple the kind of source level annotations you use from the runtime. So what that means is, in effect, is that you can use JSON annotations, or you can use JSON-B annotations for the JSON-B specification. You can use those annotations. Or if you're using Mongo, you can use JSON annotations. And we just map them all onto the same model at runtime and treat them as the same thing. While something like JSON is coupled to like JSON annotation, right? Or one of the JSON-B implementations. So we're able to support different annotation sets. So you can continue to use JSON annotations as you used to. And then also at runtime, we support running on top of different JSON implementations. So we support JSON core. So you can basically use JSON's parser and generator with Micronaut serialization for serializing and deserializing data. So we haven't gone to the point of implementing our own JSON parsers or generators, right? You just run it on top of JSON core. Or you can run it on top of JSON-P if you prefer. You don't want to use JSON at all, and you want to use JSON-P. which is a standard for generating and parsing JSON. You can use JSON-P as the runtime, or you can use BSON, which is MongoDB. Right? So there's different runtimes as well in Micronaut Serialization. So yeah, it's an interesting project, and one of the reasons as well that we wanted to do this is because we wanted to support the same kind of annotation model for Micronaut Developer MongoDB, which is coming out soon in GA form as well. So the Micronaut Developer MongoDB is essentially like built on top of Micronaut Serialization, which is so folks can understand the kind of layering of how this is going to work and interact in their application.
For users, and I think that's important, is you don't have to, if you are using JSON annotations or JSON-B annotations, you don't have to give them up. You can use them with Micronaut Serialization. So if you want to try Micronaut Serialization in your application, the steps involves will be add an annotation processor to your application, which is the Micronaut Serialization processor.
Mm-hmm.
And typically you will want to, if you are using, depending on Maven or Gradle, you have to essentially replace the module Micronaut JSON data bind by the Micronaut Serialization JSON module. And that will essentially swap the JSON data binding module by the Micronaut Serialization data binding module, right?
That's right, yeah. So it's now possible for the first time to completely remove JSON data binding from a Micronaut application if you don't want to use it, right? So you can replace it. And we've been working hard to get all the modules compatible. So it actually wasn't that much work to get all the modules compatible, relatively. But I think, we got Micronaut Security compatible. We got problem JSON, and the vast majority of modules are now compatible. I think there may still be a few that need updating, but I think that most of them are now, most of the messaging modules are working with it. So it's all ready to roll in terms of uptake in the ecosystem.
Yeah, one thing is, let's touch on those two things about how to make your code compatible. So one of the things that you touch when you talk about the why was security, right? And the idea is that before, when you wrote your Micronaut application, you could essentially serialize any class into JSON, right? And now if you are using Micronaut Serialization, that's no longer be the case.
Yeah.
And how people, what are the options for people? Because this is probably the only change that they have to do in their code, right?
Yeah. So it always was a big concern for me, in terms of surfacing security vulnerabilities in user applications. It's Jackson's default behavior of allowing any type to be serialized, right? So with Jackson, you can take any Java type and you pass it to the object mapper and we'll serialize it to JSON. So you have to be very careful when you evolve code that you don't add a property that that you need to make sure that you kind of put that JSON ignore on properties that you don't want to be sent out to the outside world. And I think it's easy for developers to make mistakes and accidentally expose information. And with Micronaut Serialization, we made the decision a bit like with Micronaut Security, which is locked down by default and then open up, explicitly, which is to say, if you want something serialized with Micronaut Serialization, you have to add an annotation to it to say this type is explicitly serializable and deserializable, or just one or the other, right? So if you only want the type to be serializable but not deserializable, you can do that as well. You have fine-grained control over whether a type is actually going to be serialized. And there are some.
That would be the serial annotation.
Yeah,
right?
yeah. And there are some escape hatches, so you can, for example, specify a package name of some introspections that you already have that you want serializable by default, whatever. But in general, we think it's better and that you annotate the types that you want to be serialized. And if you are in charge of those types, there is another annotation called cert import, which lets you declare types that are like maybe not part of your code base or part of a third-party project or anything like that. And which is also useful if you have existing types that are in a library that are already annotated with JSON annotations, because you can just import those and it will recognize them and make them serializable. But you have to actually be explicit.
Yeah, we use, for example, the add-cert import in the Micronaut problem JSON integration, because we allow to render classes that are essentially, we don't write those classes. They are part of the problem JSON Java library that Zalando open source. So we import those as well. So if you want to check it out, an example of cert import, we use it in problem JSON. I am writing also a PR in the AWS module for serializing the AWS events. So the S3 event, the API Gateway event, if you use AWS Lambda. And those classes they are like part of the AWS event library by AWS. And we use the cert import, which also support mixins as well. And the last resource is you can write a custom serializer, right? Or deserializer, which is an interface, and you can register that as a bean in the application context. Is that correct?
That's correct. Yeah. So if you have a customer requirement, you can just define a new bean, and there's some interfaces that you can implement. So you can implement serializer, which will just add a serializer. You can implement deserializer, and you can even implement an interface called cert, which is both combined, right? Serializer and deserializer pair. And this is really nice as well because Jackson has its own mechanism called modules for defining serializers and deserializers, and extra ones, and so forth. And this is much nicer because it's just integrated into Micronaut's dependency injection infrastructure, right? So I just find a bean called of that particular type, and I can write my own serialization logic for a type. And it's really easy.
I think we use it in an example with Yoda time, if I remember correctly.
Yeah.
To recap, people, if they want to try, they add the annotation processor. They configure Maven or Gradle to don't use JSON data bind, but use the Micronaut Serialization. We have instructions in the documentation of the module how to do that. And then you will have to go through your pollos and annotate with assertable those that you want to serialize. So typically go through your controllers and the classes that you are returning your controllers, so that you are taking as an input in typical add body and your pollo. Annotate those with assertable, and you should be good to go. And if you find any issues, let us know. I wanted to talk also about so we have also support for key converters in the module, which I think is can you explain what the use case for that is and why will people use those?
Yeah, so JSON keys are always strings. So it doesn't make sense to have an encoder for it because you always have to convert it to a string. So a key converter is just a converter from some type to a string type, but used specifically for serialization, right? So that you can represent any type as a key in a JSON.
Exactly. Especially this is really useful if you have a map where the key is an object, for example.
Yeah. And we do have support for like using common types already as keys. Like for example, use enums as keys. We know how to put those, make those into strings, and we know how to like all the kind of typical things. Or if something implements child sequence already, then it will just turn it into a key.
How will it work for enums?
The name of the enum property.
Do we support also like having like a toString annotated with a JSON value for enums?
You can define a JSON value on the enum itself. As long as enums can be introspected like any other work.
Yeah, because I have seen that often, like people like have the enums with uppercase, the name.
Yeah.
And then they have like the value they have like a field with lowercase, and in the toString they return the lowercase, and they annotate the toString with a JSON value. So that's great that we support that out of the box. Is there anything else that you would like to say about Micronaut Serialization, Graeme?
No, I just think it's really exciting because it's like a foundational library, like a building block, I guess you could say, or like other things. So I think the big one is Micronaut MongoDB. We wanted to make sure that we use the same kind of infrastructure for Micronaut Data MongoDB. And the cool thing is if you use Micronaut Serialization on the web tier as well, it means that you have the same model for serializing types, both on the web tier and when any operations to the database. Instead of having a different reflection-based model or whatever to serialize and deserialize objects from MongoDB, and another one on your web tier for using JSON or something, you can have the same, which is like big efficiency improvement, right, for the framework. The same meta model across your entire application. I think as we evolve Micronaut Data MongoDB to support other cloud databases and other document databases as well, it's going to become more and more important, Micronaut Serialization.
I see Micronaut Serialization as another foundation block, as you said. Yeah, pretty exciting. As we said, please check it out. Let us know if you find anything, if anything is missing from you, if you have any problems using the library. Before wrapping the podcast, I'm gonna thank the sponsors. So let me go to that section. Podcast is possible thanks to the Micronaut Foundation sponsors. We have Object Computing, the ambassador level. We have Safri.net in the bronze level. Visor Games as well in the bronze level. And we have also a new infrastructure partner with Gradle Inc. Or Gradle Enterprise. We are using Gradle Enterprise in Micronaut for the last quarter, I think. And it's we are seeing improvements in the build times. So that's something that we are seeing every day. So thanks all the sponsors. Thanks also for the community sponsors, those individuals who directly sponsor the foundation to support us. I think, Graeme, we're going to say goodbye until the next episode that we have you back. I have you back always for new modules. So that's, I guess it's always good to have you back.
Awesome.
Thanks for joining me today, and we see each other soon.
Sounds good.
Thank you, everyone, for listening. Bye-bye.